Good morning, Year 7s. Really good work this week. I enjoyed looking at your skyline pictures. They were really cool. Many of you have shown me that you're very good artists, and you kind of put my drawing of the shard to shame. So really good work, all of you guys who have your amazing drawing skills and have made me beautiful city skylines. I really enjoyed marking them. Nice work, really good work, as normal, Super 7. So, yeah, cool. What we're going to do today is we're starting a brand new unit, and it is on shape. Now, you're going to know lots of this stuff, I think, already from primary school, especially because I know you guys were largely really good at maths like last year and stuff, so I think that you will be already in a good position to know kind of a lot of the stuff I'm going to tell you today. So I'm going to try to make the video a little bit shorter and give you time to do actually, it's going to be a beautiful flowchart you're going to make for me. And yeah, so I'll try to make my video not too long so you can see that. Cool. Now, classifying shapes, guys, what that means is we're just going to be trying to kind of categorize them. So we're going to say what the name of each shape is, and also why it's called that, or what defines each of these different types of shape. That's really what we're going to do today. So if you have a look, what I've got here on this page is just 3 triangles. Now, basically, there's 2 separate ways of naming triangles, okay? One of the ways of naming triangles is to do with the side lengths. That's what we're going to be using today. The other way of naming triangles is to do with the angles. It's to do with the biggest angle in the triangle, which we're not going to use today, but which we used earlier in the year when we did angles. So in other words, the 3 triangles we won't use, the angle names for them, is we won't be bothering with the acute triangle or the obtuse triangle or the right angle triangle or the right triangle. We won't bother with those 3 because we're going to go with the ones that are based on side lengths. So anybody remember really quick, if we've got 3 side lengths equal in a triangle, which is what this blue one is here, you remember what it is? Well, if they're all equal, what kind of triangle is it? Oh yeah, it's an equilateral. If you said it was an equilateral triangle, you are dead right. What tells you that? 3 equal sides, 3 equal angles. So that's basically equilateral triangle, not playing games. 2 of the 3 sides are equal. So this one and this one are equal. That's what these little single ticks show. When you've got 2 sides equal and the third side not equal, it's the one that's really hard to spell, but it's not too bad actually when you know the trick. It's the isosceles triangle. I sat on Sam's cat. Everyone laughed except Sam. Now you totally know how to spell isosceles. I sat on Sam's cat. Everyone laughed except Sam. 2 angles are equal. 2 sides are equal. The funny one, which actually you guys all seem to know this 7CLS seemed to know this when I spoke to them about this earlier in the year. The third type is a scalene triangle. It's the funny one. It's where no angles and no sides are equal. So there's your scalene. Now basically, I've just kind of ripped through that really quick, right? It's because you're going to want to flash back and forth to this slide when I give you the activities. So this is important information underneath each one. Harder though are our quadrilaterals, my lovelies. Now, I'm sure, I think you guys would know what a quadrilateral is. I'll give you a huge hint. The word quad in it is a big giveaway. Just kind of the word, just like how the kind of starting of this word, the tri in this one, gave away there was 3 sides. The quad in this one gives away that there is 4. So if you check all these guys out, there's a whole bunch of quadrilaterals that we know. There's only one I can really think of that it's missing, and that's if you just drew any old wonky shape. So maybe I'll include it over here. If you just drew any old wonky shape, so 1, 2, 3, 4, like that. Can you see it's kind of not really a trapezium because this and this aren't parallel, the sides aren't really equal, and so this, if it didn't have anything the same, that would just be called a quadrilateral. So basically, if you don't have anything special about it, it's just a regular quadrilateral, but all these guys do. Really easy first question here then. This first guy here, all 4 sides are equal, 4 right angles, 2 sets of parallel sides, up, up, and across, and across. You guys know straight away, this is our friend, the square. What gives him away? 4 right angles, 4 equal sides, 2 pairs of parallel sides. Easy peasy. I don't need to talk too much about that. Same deal here, a stretchy square, a square but longer. So basically we have two opposite sides are equal in length, and we still have 4 right angles and and we have 2 sets of parallel lines. That, of course, the rectangle, guys. Boom. Next one here. This one I think is probably most mysterious to you. This is the most forgotten one. It's shaped like a diamond, but it's actually not called a diamond. This guy here is the rhombus. Do you remember him? Rhombuses, my lovelies, are like a square that's been kind of kicked over on a slant. So if you imagine if you were to take a shoe and push on the top of the square and it was to go on a tilt, that'd be what a rhombus is. So it's the same as a square, but there's no right angles. Instead, you have opposite angles being equal. That's the rhombus. What we've got next, my lovelies, I think you probably will know this one. It's the rectangle on a slant, and it's the parallelogram. They call it that because it's got 2 sets of parallel sides. It's just like a rectangle, but now it's on a slant. Boom, parallelogram. Oops, darn. And then we got this guy here. I like this one. I think it's quite cool. It's the trapezium, my lovelies. In Canada, we actually call it a trapezoid, which is a bit weird. But yeah, trapezium. It's really kind of a cool shape. I like it. I have a nice, easy way of remembering it as well, because in case you weren't sure if it was a trapezium or not, if you could finish the shape and it would end up in a triangle, kind of like that, then that means it's just trapezium. So in my head, if you can think of a triangle and you can cut its head off and it would become a 4-sided thing, then it is a trapezium. So here we go with a trapezium. The only thing that you have to know about it, 1 set of parallel sides. So the top and bottom have to be parallel with one another. And that's basically the only special thing about a trapezium. This guy here, next one, is an isosceles trapezium. Now, it's just a special type of trapezium. If you look at this guy, the regular trapezium, the orange one, compared to the green one, the only difference that we have is that we have these 2 guys, the connecting sides that go down, as being equal as well. It was as though an isosceles triangle had its head chopped off. And yeah, so you've got the isosceles angles at the bottom. So you've got that one equaling that one. And just kind of because you cut it straight across, it's going to be that one and that one equal also. So happy days, isosceles trapezium. Next guy here, we've got our good friend you can guess this one because it looks like the name of it. It's a kite. You could attach it to a string and it would be a kite. So of course the shape is called a kite. The only thing you got to know about it is that the opposite, it's got 2 pairs of equal side lengths. So this guy equals this guy equals that guy, and yeah, and there's equal angle on either side. So basically, if it's in the shape of a kite, then it is a kite. If you're one of those people that really likes to think about symmetry and stuff as well, you can always cut kites in half, and it'll be kind of like when you were in reception in year 1 and stuff, when you took the paint and you folded a paint over, you like painted half of a butterfly on one side of a piece of paper, and then you fold it over and it matches up to the other side. It's got a line of symmetry, the folding symmetry, and that's a kite. And our last guy here is an arrowhead. Some people call it a delta. That's okay too. They're both kind of the same shape there. So whether you call it an arrowhead, which is what I call it, or a delta, it's all good too. The only thing that's funny about it, it's kind of like a kite, but the way that I kind of think of it myself is it actually has a reflex angle in it. It's the only one that's got an angle that's bigger than 180 degrees inside of the shape, and that gives away that it's an arrowhead. Also, because it kind of looks like an arrowhead, that's another way that gives it away. So boom, there you've got it, my lovelies. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 shapes that we need to know in year 7. Cool. Now, instead of making you memorize them or make a note or anything like that you might not remember, I had a really cool idea. I'm going to make you guys make me a flowchart. Now, if you're 7 CLS, you know all about the flowcharts, because whenever you finish your tests or whatever, I give you a flowchart that basically always tells you to retry the questions to make sure they're all right and to check. So you're going to get a chance to make your very own flowchart today, whether you've seen one or not. So I just found that one online and I thought it was funny. So I put that one there so you can have a little bit of a play with that one if you wanted to read it. But I'll show you what I want you guys to do, and I'll give you a hint. I already did some of it for you. I want you to classify every single shape, which means I need you to have a box that ends with each shape, okay? So if you check this one out, see there's equilateral triangle, that's done. Isosceles triangle, done. Scalene triangle, done. Do you see how all of these paths end with these shapes? So I've actually done the triangles for you. So here's how a flowchart works. You start off with a question. So my question was, how many sides? Now, I put 3 or 4. Usually in a flowchart, 9 times out of 10, your questions are going to be like yes or no. But you can have other things as well, not just yes or no. But I started at the start just to make it easier for you to get it easier. Well, saves a box, really, if you go 3 or 4. Okay, so how many sides? 3. Then I said, because I'm the one making up these questions like you're going to have to do, I looked at them all and I was like, right, what's the difference between them? Well, the equilateral has 3 sides equal, the isosceles has 2 sides equal, and the scalene has no sides equal. So I said to myself, what would be a good question? How many sides? Well, then the next question would be, are they all equal? Because if they are, that instantly means the only one left is equilateral triangle. So where I put yes on this arrow, you've got equilateral triangle. Now, if it's no, that doesn't quite narrow it down enough, because that just means it could be this or this. So I need a new question. So it could be isosceles or scalene. So I needed a new question. And here's what my new question is. Are 2 of the sides equal? If the answer is yes, then it's called an isosceles triangle, which you know. And if the answer is no, then it's a scalene, because it's the only one that's left. So here's what you're going to do. You're going to get this section into your books, and then you're going to have to do the entire thing for the quadrilaterals, of which there are 8. Now, I'm going to give you a bit of a hint. It's pretty tricky, okay? So this is a little bit harder than it looks, and it might take a little bit of planning to get through, but I don't want to give too much away because I don't want to influence maybe how you guys are doing it. So maybe I'll just start. So okay, I'll start one for you. I'll get you know, you can do this in any way you like, okay? But I think I'm gonna get a start. I'm gonna try to get the square to come out, okay? So there's my square here. I'm gonna try to get the square and the rectangle to come out. So how many sides does it have? Now if it said 4, what would be another question? If I'm thinking to myself I want to get the square, I could say something like this. Are all of the angles right angles? That'd be a good question. Are all angles right angles? Cool. So that could be a good question. Because if I say yes to that, or I could say no, but if I said yes to that, can you see on the yes side, it only just leaves the square and the rectangle, which means that I'm pretty good to go there, which means that on the yes side, I've already limited my answers to having only the square and the rectangle. So if I said yes, my next question might be something like, well, what would be the answer if I wanted a square to come out? Well, the difference between a square and a rectangle is all of the sides are equal. So that'd be a good question. Are all sides equal? Because if I say yes to that, that guarantees then that it's a square. Because if all the sides are equal and all of the sides are right angle, well, what that means then, guys, is that the only shape that does that then is just the square. And same deal here. And so that's actually done. So I told you I wasn't going to do it. Now, oh dear, I've actually started doing it for you. Oh dear. Now here you go. Are all sides equal? No. Well, that only leaves the rectangle then. So can you see how we already busted out 2 of the shapes? There's not too many more to do. So that's it. Square and rectangle. Now that one had to be rectangle that was left over because don't forget, we're on the branch where it says that all of them are right angles. So that's only the square and the rectangle. So all your job is going to be is to continue asking questions to get all of these different shapes to join into this chart, okay? So you'll continue off of this no arrow and you'll start thinking of your own crafty questions so that you get an answer of rhombus and parallelogram and trapezium and isosceles trapezium and kite and arrowhead to all come out. Cool, cool, cool. There's going to be no worksheet today. I'm going to flick back to this slide here for you in a sec so you can push pause on the video right at the end and you'll be able to have that to hand to help you. But but I'd like for you to make me a lovely pretty chart like this, take a nice picture of it, pop it on to show my homework. Pro tip, put your paper so it's landscape, because this is going to be wider than you think. So you know how it's taken this much space just to get the two rectangle and square out. So it's going to take way more space to get all the other ones out. So you're probably going to want to have your page landscape as well. Yeah, but I guess that's it, my lovelies. Really good work. I hope that this activity goes really well for you. I'm sure it will. It is a bit tricky, to be fair. I know it doesn't sound like it's tricky when I'm saying it to you, but wait till you have to write the questions and you'll have to tell me if you thought it was tricky or not. I think it's potentially secretly a bit tricky, this activity. So that's about it from me, I guess. So really fantastic work again this week, my lovelies. And good luck and see you next time. Bye, lovelies!